pitch on its way. Swing, and he popped him up behind the mound. Guthrie calling for it. Now he's going to give way, and it's going to fall in. Nobody took charge.
Perhaps the most satisfying part of designing a projectile is perfectly modeling every aspect of it, or if you're launching something, having all the information you need to actually launch the projectile. This means using what you know to discover other key information. Let's take this one for example. Let's say this is the path you want for your projectile. Maximum height looks like about 17.7 feet. Okay, well let's take it over to the time graph. There's a relationship between velocity, time, and gravity, and it's shown here. So here's the same height, 17.7. We have height on the y-axis and time on the x-axis. Gravity is incorporated, and we can try to figure out what velocity we'll need to get it just to that height. Turns out that velocity is about 32.6 feet per second. That, in turn, tells us something about time. Let's take a look. Looks like it'll take about 2.068 seconds for it to reach 17.7 in feet when it's shot at this velocity, 32.6 feet per second. If you want to make it even more realistic, then I have to tell you a secret. These formulas are simplified. They only consider projectiles shot straight up in the air. But there are ways to incorporate angle of launch, like this. Let's turn on this line. What you can see here is the interplay between angle of launch and velocity. Turn the velocity down, it's going to go not as far. Shoot with more velocity, it'll go further. Similarly, you adjust the angle, that also adjusts the path. So we can figure out exactly what angle we would need to launch and what velocity we would need to launch to. If you want to take it even further, you want to go totally crazy with it, here's what you can do. Mess with gravity a little bit. This is normal gravity, but you can see as gravity gets less, this projectile just keeps shooting further, which means you might want to adjust the angle a little bit and maybe even turn down some of the velocity. Or maybe not. What happens in zero gravity? Well, when there's zero gravity, not surprising, this projectile just goes and keeps on going. And negative gravity, then things get really crazy. You're going to have to shoot at a negative angle to get something that even resembles a parabola. So, a lot of different options you could do. Last but not least, if you want to go crazier than any ninth grader I've ever seen, you can represent our three big variables at once. These being your horizontal distance, height, and time all at once. This can be done using a parametric equation. It looks a little like this. It has a little dot that moves that represents, and this slider represents time, while we still have our height and distance away. It might look a little something like this.
And the pitch on its way. Swing, and he popped him up behind the mound. Guthrie calling for it. Now he's going to give way, and it's going to fall in. Nobody took charge.
Projectiles are a lot of fun, and I hope you find a way to challenge yourself. Have fun.